Good afternoon, everyone. Welcome to today's Emerging Technology webinar, The Near Future of Mechanical Drive for Humanoid Robots. This webinar is in conjunction with the release of an AGMA white paper by the same name. We will send all registrants a copy of the white paper at the conclusion of this webinar. For those of you listening on demand, the paper is available for download in the same page where you see this video. Thank you. This meeting is being taped. For those of you on the live event, please put your questions right into the chat. For those of you listening on demand, please send any questions to Doran, D-O-R-A-N, @agma.org, and I will work to get your answers from the presenters. This webinar series has been made possible by generous donations through our members. Special thanks today to Liebherr, Vector Companies, Star SU, and Gleason. Thank you. I'd like to give a shout out today to the members of the Robotics Committee who helped us with the white paper. Special thanks to Robert Kuffner, President and CEO of SDPSI Designatronics, who is the chair of that event. And today's presenter and moderator is Jacques Lemire, Principal at Lemire PBD Consulting. With over 3 decades of technical and business management experience, he is also the author of the paper. So thank you so much to everyone, and Jacques, I'll turn it over to you.
Well, thank you very much, Mary Ellen. So thank you everyone for attending this webinar, and also I want to thank all the contributors to this white paper, because there's several people we had discussion meeting, pretty much in the U.S., in Europe, with very smart people. So among them, 2 of them that are I'm very proud to have on this webinar that will be part of the panel. Aaron Prackner is a Director of Robotic and Autonomous System Program at ESTM International. Welcome, Aaron. And also Brendan DeHart, who's a RoboHub Manager and Adjunct Assistant Professor at the Faculty of Engineering at University of Waterloo. So thank you for joining, Brendan, also. So to start, I'm just going to give a brief introduction, and then we're going to go with the panel and talk a little bit about this the white paper. So just to put it in the context, I just want to say that this paper is about humanoids, but in fact, humanoids are not new. Back in the 70s, University of Waseda created the Wattbot, and that could recognize objects, speak, and walk. Back in the early 80s, Honda also developed the P2 Asimo, which in a way is very similar when you look at the characteristic of those robots. So it had small electric motor, high torque density capacity, and stable walking biped. So not, in a sense, there's not much new, and also there's a lot have changed. So there's been a real surge, in the past year, and of interest in humanoid robot from investor and corporate board of director. So before we go into the panel and talk a little bit more about this, I would like to, we have a special guest, Ruben Striven from Interact Analysis. Interact Analysis is a global market analysis company. And I wanted to ask him a question. So Ruben, back in the last quarter, when we look at and we discussed this in the white paper, the headline, they predict over 63 million humanoid by 2050. There's also forecast that the industry will grow to 375 billion US by 2035. This is these kind of numbers are close to even the auto industry. So I want to just take 2 minutes of your time, Ruben, and see what is Interact Analysis and your take on these numbers and the way the market is reacting to humanoid.
Hi, everyone, and thank you very much for having me here. It's a really good question. I will answer that in just 1 minute. I just want to really quickly introduce the work that we've done, and I think that will provide a bit of context to the answer I'm going to give in a second. So we've spent the last 6 months looking at the humanoid robot market with 3 main questions that we've been trying to answer. Firstly, what is the opportunity for humanoid robots, both in terms of the TAM as well as the potential penetration of that TAM? The second key question is, what is the current competitive environment? Because as you say, there's been a lot of interest. It seems that a new company is emerging each week and a new model, potentially daily as well. We're seeing a lot of media attraction there. So trying to piece together the various pieces that are in the media today. And then finally, what are the components that are going to be used within these? So are they going to be outsourced? Are they going to be insourced? Those that will be outsourced, what are the trends going to be as it pertains to the development of these components? So we are just about to publish this report, and I believe a link will be sent to the page if anyone wants to check it out. But getting back to your specific question, when we see the headline figures that Goldman Sachs and various other providers have provided in terms of the potential opportunity, our view is slightly more conservative. So to provide some numbers, we see a very large opportunity in terms of the total addressable market. And in fact, by 2032, we project that there could be sales of 17 million units. But when I say could, that is more in terms of what that potential opportunity is. Now, what of that potential is going to be penetrated? Our analysis suggests 0.01%. So in other words, we estimate there's going to be about 45,000 units shipped annually by 2032. However, long term, we do anticipate there is going to be much stronger growth. In other words, we expect there's going to be more teething issues and a longer period of time to get product market fit than what many others suggest.
Well, thank you so much, Ruben. That's great information, and we're looking forward to this report. And by the way, for those who's able to attend this, there will be a presentation in the June Emerging Technology webinar about this report. So thank you, Ruben.
Thank you very much.
So just beside the number, and we've talked about this, obviously there's things that have changed that were not in the 1970 or 80s. Now we have AI, machine learning, computer vision, and control algorithms that are much more sophisticated than they were in the past. So that's a big game changer in the humanoid. Also is the reality that safety, reliability, and cost of electromechanical actuation still represent a significant challenge that limit the near future of commercial deployment of humanoid. There hasn't been much, not change, because, in the 80s, like I say, the harmonic drive was used and the brushless motor was still used on the motor. So not much on that, but things are about to change. And one reality, and we've learned this through with self-driving car or other type of autonomous system, is that when a humanoid robot stumbles, there's risk for human, as these machines can be heavy right now. Furthermore, stumble can damage the robot, leading to costly repair, downtime, and even compromise the functionality. So those are items that we discuss in the paper. So today we will also talk about one of the key elements that we talk in the paper is we did multi-criteria analysis of different mechanical drive system for and their different attributes. And we also will be talking about what we need to do to get into mass production of humanoids, because we know there's prototype out there. I'm sure each of you have seen YouTube video or of robot that can do great thing. So the question is, are we ready to mass produce, and what we need to do this? And ultimately, about physical intelligence, we'll talk about what what are the limiting factors in terms of safety, reliability, and return on investment to make these humanoids successful? So just want to put a little caveat here to the discussion. This webinar is mostly a technical seminar webinar, although we discuss initially a little bit the market forecast. I would like to keep the discussion within the boundary of the future impact of gear in mechanical drive in humanoid robots. So again, thank you. And then I would say, again, if you have any question after the webinar, you can always address it to Marielle and Doran. So I'm going to start sharing, and I want to welcome again my two distinguished guests, Aaron Proctor and Brandon. Aaron and Brandon, thank you so much for joining me. And I would like to start with the first question to Brandon, because you at the RoboHub in University of Waterloo, you see a lot of robots, different type of robots. So my first question is, you're operating these robots. What are the challenges? What do you see every day? What have you experienced operating those robots?
Yeah, so there's a number of challenges that I could go on about all of the various bits and pieces at length, but we're focused on the mechanical piece here, and I think one of the big pieces that we see on a fairly regular basis is that the vast majority of robots that are interacting directly with people, we still don't have a good electromechanical solution for how to do that in a reliable and effective way. Whether it's the collaborative robots, whether it's legged systems, mobile manipulators, whatever it might be. And in fact, I want to say for our legged systems, with the exception of kind of very small social robots, every single legged system that we have in the RoboHub, and we've got probably a dozen at various scales, up to my size humanoid kind of thing, they've broken a hip joint or a knee joint or an elbow or several of those things over the 5-6 years that we've had them. Some of them within the first year that we've had them.
Well, that would be a kingdom for an orthopedic surgeon.
Yeah. But one thing that I will say too is that even with the smaller, like our social robots, the older designs were using kind of compact metal gears. They weren't really back drivable, all of these things. The incorporation of back drivable setups, plastic gears, iteration over, I think they're on version 6 or 7 of this particular robot I'm thinking of, has led dramatically to them being more reliable. They're lighter. The kind of flexibility that you get in there with the majority of the joints switching over to plastic gearing and having the ability for a person to move it around if necessary means they're out of commission. They're out of kind of use far less frequently than the older designs are.
Sounds great. And I like your comment because it's a little bit counterintuitive that the old traditional way of thinking in engineering is you make it the stronger the better, and and that might have been true for the industrial robot, but in the humanoid side, we're crossing a boundary where the old rules might not apply, and we need more flexibility. And you mentioned back drivability, so that's we'll get back to this on emerging technology. Aaron, I have a question for you. So, and as you know, I'm an aerospace engineer by trade. So when I start my career at Rolls-Royce, we had like huge design handbook and all sets of regulations. So right now, if I were to design a car seat, or an airplane actuator, I would have the FAA or the DOT that would provide rules and regulation on safety, design criteria, and how to test it, how to certify. So how would I go today if I want to start Jacques Robotic now? How do I to design humanoid component and subsystem And which organization would I call to give me a guideline on design requirement?
Yeah, I mean, great question, Jacques. I mean, currently the regulatory landscape for humanoid robots is still evolving. I mean, unlike aviation or automotive industries, there isn't a singular regulatory body defining standards for humanoids. However, there are some organizations and frameworks that are starting to provide some guidance. Uh, for one, there is a IEEE study group. Some of the folks on the call, including ourselves, are in that group, and we are sort of exploring where are the gaps in the existing framework when it comes to humanoids, and how can we fill them. The good thing is we have some good standards out there that are addressing at least the beginning part. So we can look at ISO 13482 for personal care robots as a starting place. We can look at ISO 10218 for the industrial side. So we can take those types of standards and build on those. And that's one of the things that the study group is looking at, of how can we take some of those existing standards that are well known in the industry for traditional robots, if we want to call them that right now, and apply them into humanoids. For my organization at ASTM International, we're starting to look at how do you test some of these components. So as Brandon brought up, legs are tricky, and so we've
Right.
actually stood up a group that is looking at just the legged part of humanoids. Where are the failure points? Where are the tip points? And that is still in the research phase. So we have some great researchers up in Boston, Iowa State, University of Michigan, that are starting to look at these items for legs to figure out, are there just design elements we need to put in there. So that work is happening. I would
Right.
welcome anyone from this industry here to maybe look and get involved in those. But you could work with ISO, you can work with ASTM, you can work with UL. Every standards organization is looking at this from different angles. It's just, where do we fit the gear guys in?
That's correct. So that's interesting. Also, it's a global industry, and we know that even in I know part of your committee in IEEE that the China has developed recently some very extensive standard that we're still trying to digest to what extent they could be.
Yes.
Yeah.
So China is working on this as well. I mean, it is a field that we're going to need a lot of brain power behind.
Okay. Well, thank you so much. So next question. So it's to both of you, Brandon and Aaron. And in the paper, we discuss about safety. And Aaron mentioned about, I think, this #1 criteria, because failure. But we look at 3 type of safety level in terms of motion, behavior, and mechanical safety. Motion being, algorithm, how do you make either rolling or pedestrian, smooth, and how do you balance the walk around maybe obstacle. The behavior is all the decision making. It's like when you push back on a robot, will he push back, or if he has to make a choice between saving the child or doing the task, what is he going to do? So the motion and the behavior. I think in the paper we talk more in terms of semantic intelligence. They're more related to algorithm and AI, and it's like I mentioned, with the computing power evolving so fast in the past couple of years, it has made tremendous progress. On the other side, the mechanical, it's more in terms of physical. We talk more about physical intelligence. So I would like to know what's your take in terms on the physical intelligence and safety. Is there potential for development, and is there necessary to achieve greater safety in humanoid robots?
Well, Brandon, you want that one first?
Sure, I'll jump in.
Okay.
I think it's certainly possible, particularly with some of the developments that are coming out with different leg designs, joint designs, how the feet actually make contact with the ground, dealing with the impacts, whether you're incorporating flexible elements or not. There's lots of kind of pieces to that puzzle, and I think a big part of it is going to depend on what level of physical safety, what level of physical risk different environments are willing and able to accommodate, right? If you're in an industrial setting and you can lean on a pile of standards and regulations and risk management and all those things, you're going to necessarily be able to do more things more rigidly, faster, et cetera, like we've seen with industrial manipulators and things like that. But if you're in a public setting, right, you're on a sidewalk, you're in a hospital, you're in an airport, whatever it might be. And we've talked about this for ages in the humanoid research community, that effectively you need like a Baymax type, big fluffy pillow robot to mitigate all the risks. So it's really about how far you need to go down that channel for different applications and different environments.
Yeah. I mean, I would really add, I mean, everyone's been talking about the chat GPT moment for robots. And yeah, all the pieces are coming together, but the question I'm starting to have is the hardware side really going to keep up with all that advancement on the software side?
Right.
And I think like one of the number one concerns that is really out there is you're seeing these humanoids and on the back of their neck they have an e-stop. Okay, what happens when I hit that e-stop? What's going to happen next? Is he just going to tumble down, or are we going to design some of the joints to maybe just lock up, and they don't need power when they do that, but that keeps the robot up and steady? But is that now another safety issue? So it's these questions of how do we take some of the designs that have been the cornerstone? Robots have e-stops on them. Well, are you going to put those out in the public? Because I know a bunch of teenagers that will probably go to town on that thing and keep hitting the e-stop on them.
Right.
So do we have to rethink that? But then if we hit the e-stop and that kills power, how does that put safety at risk?
Yeah.
So I think even though we're talking all great about all the AI that's going on, we still need a lot of work on the hardware side to make this a reality.
Yeah. So another point I wanted to bring, Aaron, is again, traditional engineering, when we design a gearbox and mechanical actuator, it's often we say, well, I will try to design it to have as long as possible service life. And people say, well, I will do a L10 prediction and can get a million cycle. And that's good, and it's a probability, but knowing that those humanoids, they will wear, and there's going to be tear over time. And whatever at the University of Waterloo RoboHub, you're not going to use it the same way that I might use it in my industrial setting. At what point are we going to let those humanoid robots fail, and to lock somewhere in the middle of a task? Or there's going to be more concerted effort to have like complete maintenance cycle where you say, every 500 hours you go back to factory for complete overhaul.
I mean, there's a couple of pieces in that question, and I'll just hit on two of them. One of them is, as we've all seen with cars, with computers, with anything that gets to the point where it is massively distributed among people who can't necessarily, these days at least, can't necessarily fix it themselves, repair it themselves, take it apart, put it back together. They don't have the tools, they don't have the experience, the knowledge, whatever it might be. You'll have entire cottage industries popping up that are then going to be putting in a replacement gear. They're going to be putting in a new gearbox. They're going to be randomly slapping a motor on the side and putting in a right angle U-joint to drive something, right? Like you're going to have those kinds of things happening. So it really needs to be, it needs to follow that same kind of consistency with vehicles, with desktop computers, laptops less so, but desktop computers, things like that, where a lot of these interfaces and connection points and whatnot are going to have to be standardized to some degree so that there can be repairs, replacements, et cetera, made, because they are going to wear, and that's going to significantly impact how they behave. And I think, I mean, to tag on to what Aaron was saying as well with the other part of what you were talking about, if someone hits an e-stop or kills the power or the battery dies or, you know, whatever, there's many different circumstances that will result in there being no power. The entire safety of that system is now completely dependent on the design of the joints, because it's not a passively stable system. It's not like a car that if it breaks down and the engine won't start, the car is sitting there stuck. If
Right.
you have a standing robot, a balancing robot, and things lock up, it's going to fall, it's going to crush something, it's going to break itself. You know, it's not a thing that can just sit there if it's broken. It will fall over. It will be a rag doll, but a rag doll that weighs potentially a couple 100 pounds.
Yep. Yeah.
Go ahead, Aaron.
Yeah, I mean, I think there's gonna be a high demand that all the parts going into a humanoid should be durable, they should be reliable. Nothing, but the whole thing is I think we're definitely going to have the concepts of modularity, as Brandon was saying, so we can swap those out as they break, because they are. I mean, and it is sort of interesting that some of the first companies that are taking up humanoids are automotive companies. Either they're part of an automotive company or they're being partnered with an automotive company. So I think that this could be a real interesting play of, could the humanoid companies learn, if they're not already part of an automotive company, of those kind of concepts of, yeah, build for durability, build for reliability, but also build where you can just take your robot to the local robot garage down the street eventually,
Right.
and swap out those parts. So there could be a whole new industry being formed for this kind of stuff. But it is just, I think we need the reliability, we need the durability to convince the public that these are safe and that they can do what we're saying that they're doing. But you also need to build long term where you can swap parts as needed.
Yeah. Thank you. So in the white paper, we address some of these issues, but also we did the multi-criteria analysis evaluation, looking at the ratio, you know, mechanical ratio, the backlash, the back drivability, the weight, torque density, reliability, efficiency, and cost of 5 types of what seem to be the type of rotary humanoid drive, like planetary, harmonic, belt pulley, roller, planetary traction, and cycloid. So among those attributes, those 7, 8 attributes, you know, because we're still at the infancy of this humanoid, then if we know that these will become critical to do mass production, which of those would be, you think, should the industry emphasize in order to reach commercial success?
I mean, there's a few pieces to that puzzle. And the challenge is going to be that with something like a humanoid, whether it's walking around on legs, whether it's on wheels, stable base, not stable base, etc., different pieces of the system have different requirements, right? Precision and you know, reliability is much more important in something like a finger joint than it is in a knee, but the ability to withstand impacts and shocks without a gear train breaking or teeth coming off or whatever in a knee or a hip is far more critical and far more important, right? The difference of where you put your foot, if you're walking from one inch to another, is far less critical than where you actually poke a finger or grab a mug or, you know, whatever, and how much strength you apply to that, right? So the kinds of motions, the kinds of measurements, the kinds of reliability, and all of that that's going to be necessary is very different. I think one of the other big things that doesn't get talked about enough when it comes to legged systems, when it comes to kind of human-robot interaction, is that you have low numbers of cycles and low revolution counts in most of these systems. Unless you have massive scaling like a harmonic drive or something, typically if you're going for a low inertia system, you're going for a back drivable system, your ratios are going to be in the single digits, maybe double digits, right? And as
Right.
soon as you get to that point, and maybe it's only rotating through 60% of its range at the output end, or 40%, right? That piece has to be really reliable, but you can then do some optimizations with that system to focus on just that piece, right? And we've seen that with servo designs and things where, you know, most kind of generally applicable and usable micro servos, medium scale servos on the kind of mass distribution side, they maybe only rotate 90 degrees or 180 degrees, full stop. And everything is focused on that, right? I feel like there's going to be some focus, there's going to need to be some focus on that kind of fully integrated actuator. It has all the bits and pieces. It's got encoders front and back. Potentially, they've all got torque sensors on them, like most of our robots do, so that they can safely feel how hard they're pushing on the world, how hard the world pushes back. And one of the other major ones that doesn't really get thought about much for like fixed based robots, let's say, right? Industrial manipulators and collaborative arms and things, is all of the wires, all of the boards, all of the everything has to live in that arm. So as soon as you add power, as soon as you add cabling, generally you need to pass through the motor, through the gearbox, etc., because that is actually a structural element. You need to do cooling often, right? Like there's lots of other pieces to that puzzle that come into play that we don't really, they're not really an issue when it's not a mobile system with lots of moving parts.
Yeah, I mean, Brandon really nails it there. I mean, I think, and there's been a couple questions that pop up and have been popping up in the chat around this of just we just don't have a lot of data yet on some of these applications and how humanoids are going to fit into them. We know that industry is probably going to want 8 hours of work every day out of them, if not more. Okay, what's that going to look like when you look at energy consumption and just going back to the reliability question. But the whole thing is also we might not even get to that data until we hit some kind of critical mass, and everyone's saying what's holding us back on critical mass is the cost of the part. So it's like, okay, we're stuck in between these two worlds of like, what do we do? And the whole thing is when you just look at humanoids of what environments are we going to put them in, what's the safety requirements going to be needed per that industry? I mean, if I'm going to put a humanoid, say in Fukushima, to help clean up, I really don't have to worry about human safety anymore. I mean, because there's not going to be any humans around it. But if I'm going to put a robot, say, in a mall to hand out samples to folks, okay, I got to worry about a lot of stuff. But how long is that robot going to be working during that shift and going back through? So the whole thing is I think this is one of the struggles even the humanoid folks are having, because they don't even know what their use cases are yet. They're throwing some stuff out there, but we don't have enough data to tell us, okay, what are those cycle times? What are those requirements going to look like? So we're so early on. It's an exciting time, but man, we have a lot of questions we got to still get answered on a lot of these fronts.
Sounds good. Well, I want next point. I want to bring something that Brandon brought up in terms of integration and just looking at it like maybe movement. We need only 60-degree movement. In the white paper, we look at technology that kind of have evolved over the past couple of years, and we look at 5 of them. First, plastic gear, and you're gonna say, well, plastic gear have been around for many years. However, we got new tools right now that we can compute a little bit more better their nonlinear behavior or thermal dependency. We know that plastic is not as stable as metal in in a different temperature range. And also, we don't have the data and in terms of the SN curve or service life curve than we have on metals. So this has evolved, and also plastic gear with these tools, we probably can start doing, I would call it funky design gear. It's like things that wouldn't have, you would not want to put on a CNC machine because it would take forever. But if you can mold it, it can be hollow. So that's one thing. And the other element that we look in the paper is nanocomposite coating. Again, nanocomposite has been around for a while. Now it's becoming more and more economically feasible. And with this, you can basically have gear that increase efficiency, maybe being able to reduce the mass of those gears, those mechanical systems, and lower lubrication dependency. Therefore, again, smaller, lighter, more flexibility. We talked also about the point that you touched, Brendan, about better integrated actuation system where we could have, so the industry has been, traditionally you have the gear people, the motor people, the sensor people in the controller, and you put like a controller on top. I've seen motor with the top, it's like a well humpback, type of design. Just it's an add-on, as you add on the gearbox. Knowing that nothing's going to be perfect. Starting to think about, having dual sensor, where you measure your input and your output system, and having plastic much more integrated, knowing that you don't want a planetary that does 360 degree, but you just need the 90 degrees. So kind of a 60-degree planetary kind of. The other thing is the simplicity, and I like the often we're all engineers. We tend to make things more complex. We had like bell and whistle, because why we can do it, that there's this new thing, but there's about going back to the roots, exactly defining each joint. We talked about what you need on a finger, the actuator on a finger or hip, completely different. One high torque, one low torque. So maybe more mechanical, simple solution. And finally, looking at joining these technology together. Like, why not have? We discussed about something that's emerging, having nanocomposite coating on plastic gear, so you get the form factor, maybe improve lower weight, improve the durability and strength of the plastic. So, so my question is: do you think is it still worth investigating those technology, or basically it's already too late? Because the investor are already put billions of dollars into the humanoid market, that the train has left, the train station, so it's too late. What's your take on this?
I think I'll take the easy answer and then leave Aaron for the easy answer is that it's not too late, because the vast majority of companies that are building humanoids right now are building them based on 10-year-old mechanical technology, 10-year-old electrical technology, and then using their AI, because most of the companies building humanoids these days are actually just making them as a demonstration platform for their AI tools. They're using the AI to compensate for not having the latest hardware, not having the latest gears, motors, drivers, etc. So if investment is made right now into some of these integrated systems, lighter, faster, lower inertia, more longer lasting systems, whether it's nano coating, whether it's simpler design, whether it's replaceable parts, whatever it is, that is very easily going to become the way that this moves from the one-offs and the 10-offs that we're at now to the mass production 1,000 at a time, 10,000 at a time that is being predicted in the next kind of 10, 20, 30 years. I don't see diving into any of these things as not working. So for example, like our small social robots, like I said, I think they're on version 6 or version 7 right now. We also have a V3 from back before I started my grad degrees that was 10 times as much. And the vast majority of that cost came from big, dense, easily breakable gear trains with teeny tiny gears, and not having the advantages of the smartphone market to provide them with a 2-cent camera and a 4-cent accelerometer and an 8-cent, GPU
Right.
combo for inside the head, right?
Yeah.
Mass production is what has enabled them to go from that price down to the 5K, 10K that they're at these days. That is necessary to get the humanoids. And yes, everybody's talking about, oh, you can buy one for 20K, 30K. Yeah, that's they're doing like a 90% loss leader there at a minimum.
Yeah.
It's not there yet. So any developments in that space are going to be dramatically helpful.
Thank you, Brandon. So you provided the easy answer. Aaron, you have to
Yeah, I
to
gotta
provide the tough.
Well,
the
I mean,
tough answer.
I'll try and build off of what Brandon set us up with I mean, the humanoid market is so early right now in its commercial stage, and yeah, they're working off older ideas. Um, so if anything, it's not too late. There are some great projects that have been happening at the lower TRL levels that probably need to get a kick in the butt, to say the least, and get moving up the chain. Uh, I really think uh, if we can figure out how not only to make the parts cheaper, does that help, but also how can we make the parts where they're lighter so that if we do have a fall, it's not 100 pounds of weight coming down on you. I I know that there's been some work in how could we integrate actuators into other parts and then cut down on the total part count altogether. Uh, and I've seen some folks trying to do some of that work, but they just don't have all the data on the material. So they don't know
Right.
how to model the material correctly in simulation. And I think I mean, that's one thing we haven't really talked about, but I think how we're going to figure out some of these cycle times is we're probably going to have to lean on some simulation softwares. But we also need to have good data points going into that simulation, and that's where I think we're starting to see. I know ASTM, we work on a lot of material sciences. It's actually the M in our name is based off of that kind of science. So it is going to be of how do we get some of this stuff that's in the lab and academia is working on it, but they're not even seeing the full pathway yet for it. If if industry is starting to see that there is a pathway because we can check some of these boxes and make plastic gears stronger and more durable through other uses, like is there another nano composite coating out there that we just don't
Right.
know about?
Mhm.
So I think it's going to take a village. I mean, I hate to use the term, but you got to bring a lot of key players from different aspects together to address some of these. But there is some rumblings down there at the academia level. We're starting to see them bubble up in some of the research papers coming
Right.
up, but it's like my question is, okay, where's this research paper going? You ask the researcher, like, I don't know.
Mhm.
I have no one's carrying me the rest of the way. So it's how can we connect some of these players? How can we use some of the bridge groups here in the United States, like the ARM Institute in Pittsburgh, so the Manufacturing USA institutions. We have some great institutions in Europe that could help out on this. So it's how can we take what's bubbling up in the lab where they are trying to solve some of these problems, but show them a pathway to commercialization, because that's ultimately what's going to that's where the money comes in. That's when we start having the breakthroughs. So if anything, I think we need to come together more as a group. And what's great about this organization is you guys already have the group. It's just
Yeah.
how do now we connect you to the other folks. So it's very doable. It's not too late. Uh, and you can just tell that, as Brandon said, they're using older stuff.
Yes.
How do we get them to the new stuff that's happening actually right now in the labs?
So yeah, that I think you bring a good point. Sometimes it's almost worth stepping back and look at, okay, what have we learned in the past, 5, 10 years, on these robots? We talk about the reliability, maintainability, the weight, the inertia, the back drivability, and integrate, start into getting the solution. And there's there's no, because Aaron said that there's no rule book. No one say that you cannot have the actuation being part of the structure, because right now they're built. You build like a skeleton and you put the actuator. Why there's no rule that say it has to be separate. So um, let me before we run out of too much time, and I want to take some question at the end. So again, another tricky question for both of you. So the paper, we discussed the difference between industrial robots and humanoid, and they're very different in terms. In terms of the environment they operate, industrial robots typically are within a cage. You don't, and they're pretty massive. They generate a lot of force, and they move quickly. Typical example is on the automobile assembly line. In terms of their capability, I mentioned we're talking precision, and predictability. Their tasks are known. While the humanoid, we don't even know the cycle. We don't know, is it going to operate in the mall or in a war zone, and the user. So industrial robots are typically, they've been programmed or maintained by knowledgeable staff, and there's not going to be a teenager or that will push the e-stop or try to put this finger between two joints to see if it can squeeze something. So the robotic industry, in a way, the industrial is quite mature, and we have what I call the big four, ABB, Fanuc, Kuka, and Yashikawa. These four, they know everything about robots. They've been the billion-dollar corporation. So why these four companies have not entered the humanoid product development or commercialization of humanoid robots, at least officially?
Well, I'll say that sort of tells you how early on humanoids still are when you don't have the big four coming to the table yet. Because I mean, you can almost look at it from a point of view of mobile robots. Not all of these companies do mobile robots, but some of them do, or they have a strong partner that they partner with on mobile. So it is they're very conservative in how they're moving on this, but until they see the use cases and they make sense versus what they're already selling, they're probably not going to take up the challenge. If you talk to some of those executives, they're still trying to figure out what's the humanoids going after that we're not already doing.
Mm-hmm.
And so it does again just show the infancy of humanoids at this point in time. But the whole thing is don't rule out that eventually they might, because if we had asked this question about mobile robots 5 years ago, none of them had any kind of mobile play at that time. At least two of them now have direct where they actually are doing mobile robots, and the other two have strong partners that they work with on a regular basis on this. So it's going to take a matter. It'll take time to get there, but as soon as somebody figures out the right use case, where this makes sense, where the humanoids can definitely take on the market, you'll see somebody jump. It
Mm-hmm.
will happen. But then the question will be, are we ready on all fronts? Or is it just they're going to go now because they see an ROI, but it's still not the best ROI, but it's good enough for them.
Yeah.
And that's going to be a business by business decision, but it will come. It's just when. Is it next year or is it in 20 years? We still don't know yet.
So you
And,
mentioned, go ahead.
well, now I'll just say that Ruben's earlier projection, sort of shows where that that's going, or where his group saw the numbers and where everyone else is seeing the numbers. That just shows you why you're not seeing the big four jump right now.
I think the other, very quickly, because I know we want to get to some questions, but the other major piece is for companies at that size and that scale to jump, there needs to be rules about safety, deployment, standards, etc., how they're going to work, who's responsible, where the liability sits, all of those things, none of which exists for any self-balancing system, whether it's a Segway or a humanoid or a quadruped. It just doesn't exist. So there's no rules, there's no regulations, there's no laws attached to them, there's nothing at this point. So it's very much a Wild West when it comes to the regulation, the standards, the liability, all of that. And those big four companies can't afford to be in some kind of dispute, legal argument, etc., if a humanoid falls over and crushes a person or breaks a car or whatever it might be, right? They're just,
We can confirm that. Yeah, I mean they didn't jump until the first mobile robot standards went out the door. So Brandon's doing my job for me, but that is exactly true.
Yeah, I would add probably also the commonality right now. If you look at the 100 plus, humanoid robot company in the US and Europe, they're probably 100 plus type of design. They're all different. So I think probably it could be the big four will make they look at the ROI in terms of economy of scale and supply chain management. How can they get one mechanical drive that will do multiple platforms, that will be able to work under military robot, the one that will do maybe in hospital care, or and also do like service in industrial. So yeah, it's very good comment. We have a couple of minutes, so Mary Ellen, I would like you to see if we have if there's questions that came in during the discussion that our panel could answer.
Hi, Jack. We do have a few questions. I'm going to combine a couple of them, though. So there's a question about considerations for linear drives, and there's also a question about what types of drives are being used in general. And they mention planetary, harmonic, cycloidal. So the question is, what types of drives are you seeing on these newer robots? And are there considerations in the linear drive space? I think that can be one combined question.
Yeah, there's again, as Jacques was just saying, there's dozens and dozens of different designs out there right now. And I can tell you with certainty that every one of those drive systems is on several of them. And many of them use multiple drive systems depending on what they're doing. So lots of times harmonics are kind of the go-to standard in robotics, which you're all very aware of when it comes to industrial manipulators. Because they're generally not backdrivable, or not backdrivable without sensors leading to the electronics, making them seem backdrivable, I'll say. Often it's entirely dependent on where the robots are actually getting their applications defined as what their space is, right? And many times we're actually seeing interesting things where a rotary drive is actually, an arm is put on it and a linkage is put on. So it's actually moving something linearly, but it's a rotary drive pushing it. And in other cases, I saw a really excellent hand, for example, that was driven by a dozen micro linear actuators. So it really depends on what piece you're looking at. And I think, especially based on the modularity conversations we've been having and some of the trends that I've seen coming through, I have a feeling that we're going to end up with a small group of companies making hands, and a small group of companies making arms, and a small group of companies making legs, and another one making balance system. Like it's going to be, as Aaron was saying, it's going to be a village effort. And each of these humanoid robotics companies that are coming out right now potentially will end up being, the robot head company, or the robot foot company, or the, whatever, if they have a really good idea of how to do that one piece, right? I think on the drive system, it's going to be the same thing. It's going to be dictated by application and dictated by environment.
Yeah, I would add this. What I've seen is the drive has been mechanical drive has been driven a lot by the industrial robot and industrial automation. And on the humanoid side, we see a need for lower gear ratio and lower speed, and not necessarily the level of accuracy that we you can see in industrial automation. So now, having said this, doesn't mean that you don't need to know where you are in space, or in terms of applied force. So I think the concept is that the old concept was to avoid error or minimize always your error in your system, and which drive the cost, which while what I see a trend in the humanoid say, okay, we will accept the error. We know it's not going to be perfect, and we will have different type of motion control as that where control will be in a position control and speed control, and after that maybe a force control movement. So maybe dual stage type of actuation where you go macro movement and micro movement. So I think we need to. There's still I would say the jury is out with which type of actuation system will win. But I think we need to embrace more a combo, even within the same joint within an arm, where you could have the macro movement that is completely, low cost, low accuracy, maybe higher speed, and where you do the fine tuning later on, maybe with the linear actuator. So.
Yeah, I would say, and I'm seeing some of like there's a question about the safety standards, synergies with medical. Yeah, I think we're going to be looking at humanoids on a case by case basis based off of where they're ending up and all that. And maybe that drives almost like you have different versions of the same humanoid, but where are they ending up? And it's only until you pop the hood and you see the gears are different on that humanoid versus that humanoid based off of where they're going. So this goes back to modularity, goes back to design. Uh, I mean, I think we're going to see some great stuff in the future, but it's how fast is it going to scale? Where's the ROI for everybody on this? But I think this is the time for everyone to get creative and solve some of these really unique problems, because if we are going to build robots that are supposed to go now everywhere, what's that going to look like? And what do they need to have to be successful? So I agree with Brandon. I think you're going to have new companies that are focused on very different aspects, but then how do they all come together? And again, maybe we're following the automotive industry and we're following that path.
Yeah, I mean, there's a few questions here that I'm going to try to fold together here, where there's questions about kind of lifespan and questions about, obsolescence and lifetimes and duty cycles and all these things. I think for the most part, we're going to end up with a automotive style, every X kilometers or X hours or X whatever, you should check your gears, check your lubrication, check your oil, switch your battery, whatever the things are, because many of these systems are going to be consumables, or they're going to wear out to a point that they're not performing their function anymore. So it's going to get to a point where those things are learned, right? And as with, automotive manufacturers, originally it was like, oh, every 10,000 miles. But then now they've been, maybe they've switched to 8 for some things and 16 for other things, whatever. So as those duty cycles and as that learning comes through, then we're going to figure out what those different pieces look like. But the critical piece that's going to be the case for a while still comes down to, these are mobile systems. They are electric. Their batteries have to drive everything. So whether it's your smartphone, your electric car, your mobile wheeled robot, your walking robot, whatever it is, it has to carry its own battery, and every single pound that you can save means you either have a longer battery life or you can use a smaller battery. And all of that has a whole chain that affects things down the line. The lighter stuff is, the lower inertia, the more efficient it is. All of those things are going to mean the battery lasts longer, and or you can have a smaller battery that then charges faster, whatever it is. So because these aren't bolted down, because they're not hooked into mains, the battery for all of these things is always the driving factor. And the mechanical design of the joints is the primary weight concern for humanoids because they have dozens of joints in their system.
Thank you, Brandon. So, Marilyn, I think we're pretty much up to our time now.
We are, and in honor of everyone's time, I'd like to say thanks so much to our panelists today for having this discussion. These are discussions that we have in our emerging technology committees. Those committees are open. Please, if anyone is interested, let me know and I can get you involved with that. Our webinar for April will be Joe McCabe with Auto Forecast Solutions, talking about what's happening in the auto market right now. Our May webinar will be on 3D printing. And then our June webinar, as we said, will be a presentation from Interact Analysis on their humanoid robot report, which should be available in the next 10 days. At the conclusion of this webinar, we will send out the white paper and we will make this recording available on our website alongside the downloadable version of the paper. Thanks everyone for your time today and have a great rest of your day.